Hi everybody, it's Camille from Physiology for Hippies. Today we're going to answer the age-old question, what is P-glycoprotein? So here we go, short answer. It's an efflux membrane transporter, also known as a multi-drug resistance pump. All right, are you good? Are you like, okay, no, Camille, I think we need to back up a little bit. All right, so here's what I want you to do. Imagine that you are an intestinal epithelial cell. So you're there, you're in the intestines, and somebody's just eaten recently, so all this stuff is floating by. You've got all kinds of macronutrients, and maybe they've just taken some sort of medication, so that's all mixed in there too. And your job as the intestinal epithelial cell is to absorb things, right? And then presumably anything the body still wants, it's going to go into the blood, it's going to go to the liver via the hepatic portal vein, and so on and so forth. Okay, so that's you. You're the intestinal cell. However, what if something comes along and you're like, ooh, yeah, I don't actually want that. That's a no. Do you have to automatically send it to the liver and be like, well, it's the liver's job to deal with this? No, you have another option, and that is where P-glycoprotein comes in. So let me show you right here. All right, so here, this is a cell membrane. Hopefully you recognize that. Out here is the external world. In this case, that's going to be the lumen of the small intestine. And then in here is inside the cell. So here, in this case, we're using a drug as our xenobiotic. So the drug is coming along and it's getting absorbed through the cell membrane, but the cell is like, ooh, no, we're not interested in that. And so you can see it's basically going right back out. Right? So it's getting absorbed and then the cell is like, okay, goodbye. See you later. It's getting pumped back out. This is P-glycoprotein. This transporter here that's pumping it right back out, P-glycoprotein. This is considered what we call phase 3 detoxification. We can get into that more some other time. So it's essentially detoxifying the cell in a non-specific way, meaning the P-glycoprotein is not specific for an individual drug. There's not different ones for different drugs or different xenobiotics. It's just there are certain substrates of P-glycoprotein, and all of them will get pumped out like this. So how much gets pumped out is just a matter of how much P-glycoprotein is on the cell membrane, being expressed in the cell membrane. So there's a lot of things that get pumped out of the cell like this. Some of the big ones that might be of interest to you are things, certain medications, like, for example, corticosteroids, or certain types of antibiotics, cyclosporin, methotrexate, some of these big ones. Okay, so this gives essentially the epithelial cell some power to get rid of things that it doesn't necessarily want to send on to the rest of the body. Now, in case this diagram is a little bit medical and weird, I made my own. It's okay, so here's a cell, and here's something that's getting absorbed into the cell. And then the P-glycoprotein is essentially like, nope, go right back out. That's the super basic version. Where are these things located? Well, they're largely found in the intestinal epithelium, so the lining of the intestines. But you're also going to find them throughout the GI tract in, for example, the pancreatic ductules, the bile ductules. They can be the proximal tubules of the kidney, the adrenal glands, the endothelium of the blood-brain barrier. These are all places where you might have this particular protein being expressed. Now, one thing that I do want to end with, and a reason why a lot of people are starting to look into these more, is that the expression of P-glycoprotein on the cell can be modulated by all kinds of factors. So how much P-glycoprotein is there depends on how well some of these medications will get absorbed. So we know things like the composition of your gut flora, and even the time of day. They have circadian regulation. We also know that stress, inflammation, dietary factors can all affect the expression of the P-glycoprotein. So people are starting to look into how might this affect drug metabolism. Are there better times of day? Are there certain people or certain gut flora compositions where we might want to modify our drug doses based on somebody's P-glycoprotein expression. Lastly, I also just briefly wanted to mention that in many neoplastic or cancerous cells, they have an overexpression of P-glycoprotein. So this particular cell is what we consider drug resistant, because a lot of the drugs that we are giving people to treat cancer, these cancerous cells are just ejecting them via this P-glycoprotein mechanism. So some people or some researchers and clinicians are now working on strategies to try to influence P-glycoprotein levels concurrently with administering medication. The problem with that is that we also know P-glycoprotein doesn't just do this thing. It's not just a pump, but it also seems to have important regulatory effects on the innate immune system. So if you start to shut down P-glycoprotein function, you may also have negative effects on the immune system. And so there are, of course, consequences. There's costs and benefits for everything. So we're still learning a lot about this, but I think it's pretty cool stuff. All right, thanks so much for watching. If you have any questions, let me know, and have a great day.